All right, this is number 13 from your review. Essentially what they want us to do here is basically solve for the equation of the polynomial using the information that's been provided to us on each of these two graphs. So I'm going to do part A. I think we'll call it a part A, maybe f of x again. All right, so that's the function f of x. F of x is going to equal, okay, we're looking at the roots. Okay, first things first. So I'm just going to write down some factored form. Remember, I'm going to put an a value out front because I know I'm going to solve for it. So it kind of specifies which of the functions from a family we are actually talking about. And so what I'm going to do here is I'm just going to write out the factored form of this with the a value out front. So I have a root of -2, which means the factor is going to be x plus 2. And then I also have a root at +4, which makes the factor x minus 4. And you'll notice that it looks kind of quadratic at x minus 4, and so we're at +4, I suppose. And so we're just going to put it looks quadratic there, right? So we just have that double root on it. Now, they've given us, I think, another point on the graph that wants us to specifically use it to solve for the a value, I'm presuming. That point is 2, -16. Okay, so that's the point I'm going to use to solve for the a value. So -16 is going to equal to a 2 plus 2 multiplied against 2 minus 4 squared. So that's going to be -16 is going to equal a times 4 times 4. Okay, -2 squared. And so you're going to get -16 is going to equal to 16a. Divide both sides by 16. A is going to be -1. So I rewrote f of x. F of x would be -1 x plus 2 x minus 4 squared. Okay, and that seems to check out. That's a cubic. Very much looks like a cubic in A, right? In addition to the fact that that cubic would have normally gone from quadrant 3 to quadrant 1 kind of thing, and it's going from 2 to 4 now, so we can tell that it's been vertically reflected. Our a value has indicated that when we solved, okay? So same thing for question B. That's it for question A. You're just identifying what the roots are, and then you're going to solve for the a value. Okay, so in question B, we can call this one h of x if you want. H of x is going to equal some a value. We're going to solve for it. X plus 2, that's this root here. Okay, and it looks a little quadratic there. And so we're going to say it's squared. And then the graph turns around and goes back up through what looks to be x equals +1/2. And so the root for that, or the factor, I should suppose, sorry, the root is 1/2. The factor will look like 2x minus 1 if I were to back solve for that. It goes up and comes back down through x, well, through 4. So the factor is going to look like x minus 4. Okay, I'm seeing 4 kind of roots. There's the quadratic looking, or the double root. This looks very much quartic. Now we're just going to pick the point that it has specified. Any of the points on this graph will work if you can clearly identify one. Like I might take a guess and say that may be a point, but maybe not quite. They have specified which point for you to use, so use it. That is the point 1 and 5 if I'm reading off my graph. Okay, so it is specified that it's going through that point. And so 5 is going to equal to the a value multiplied by 1 plus 2 squared times 2 times 1 minus 1 multiplied by 1 minus 4. Okay, you're just going to do the math and all the algebra on this, right? And solve for the a. So 5 is going to equal a times 9 times 1 times -3. Okay, and so we're going to have 5 is equal to a times -27. And so the a value in this problem is going to be 5 over -27. Okay. And so I can rewrite h of x as -5 by 27 x plus 2 squared, 2x minus 1, and x minus 4. Okay, so that is the specific member of this family with all of these roots, whose a value is negative 5 over 27. That seems to check out. As we said earlier, a regular quartic would have gone from quadrant 2 to quadrant 1 in some capacity, right? So the two end behaviors would have both gone towards positive infinity in the y direction, as x went to positive and negative infinity. And so we have vertically reflected that x to the 4 graph as seen in part B there, the red graph. And so I should see, or my calculations should spit out a negative a value to indicate that that vertical reflection has occurred. Okay, and that's it.